Hello everybody, and welcome to your linear algebra review on Gaussian elimination in two variables. My name is Jason and I work for the ASU Tutoring Centers. Now we're getting into the process of solving your matrix equations. So actually solving for what the variables x and y or x1 and x2 look like. So how we do this is one process is called Gaussian elimination. So what this process is all about is you do elementary row operations to get your matrix into row echelon form. You're trying to get your matrix into row echelon form. Now, what is row echelon form? Okay, so it's a specific way that your matrix looks, and it needs to follow these three rules. Okay, so the three rules for each row in your matrix, the first non-zero term is a 1. So if you look at some arbitrary row of your matrix, you should have possibly some zeros out front, and the first thing that's not a 0 should be a 1. And then you're allowed to have whatever you want after that. You know, you can have 87, negative 12, pi, whatever after that. But the first non-zero term in your row should be a 1. Okay. Second rule, as you move down rows, let me specify. This 1 that we have up here, we're going to call this the leading 1 or the leading coefficient of that row. That's what we're going to call this 1. So this here, that's your leading coefficient, your LC. Okay, cool. So rule number 2, as you move down rows, your leading coefficient, so I'm just going to put LC, moves further right. So if I were to have another row of my matrix below this one, I should go further to the right before I have my leading coefficient. Okay, it's further over. I can't have it directly beneath it, so I can't have this. And I can't have it to the left of it. So I can't have something that looks like this. That's not allowed. It has to be further to the right than in the row above it. Okay, so we just keep moving further to the right. Now it doesn't have to be directly to the right, right? It can be several spots over, so we can have another couple zeros before we have our leading coefficient. But regardless, it has to be further to the right. And the third rule is any rows of just 0 are at the bottom. Okay, so if we have any rows that don't have any leading coefficients, that are just zeros all the way across, they have to be at the bottom of your matrix. You can have as many of them as your matrix dictates, but it has to be at the bottom of your matrix. Okay, so let's see these rules in action, and let's get our first system of equations into row echelon form. So we're going to be using this to solve our system. So what we're going to do is we're going to set up an augmented matrix. So we're going to take the coefficients here, and we're going to augment with the coefficients over there, -7 and 3/2. Now, if you haven't seen my previous video on taking a linear system and rewriting it in terms of a matrix system or an augmented matrix, I highly recommend checking that video out. But this is what the augmented matrix looks like, this thing right here. So now we're going to start doing our elementary operations, okay? So the first thing we need to do typically is to get a 1 in this top left position here. Now there's several ways we can do that. We can just straight up divide. So like divide the first row by -5, and then we'd have that 1. We can also start flipping things around, right? We can interchange rows and then maybe divide. And in this case, that might actually be easier, because if you look in our second row, there's sort of this repeating 3. There's like a 3 here. There's a 6, which is a multiple of 3. There's like a 3 here. So dividing out by 3 would make nice numbers. As opposed to up here, dividing out by 5 would make some pretty gross fractions. right? So it might be easier if we can first interchange our rows, get the second row on top, and then work on getting that leading one in the top left position. So let's do that. Let's interchange our first row with our second row. -5, 1, -7. Cool. And now we can get that leading one. So we need this to be a 1. And how we're going to do that is we're just going to divide by 3, or equivalently, multiply our first row by 1/3. Okay, so I multiplied my first row by 1/3, and that's what I'm left with. My second row is unaffected, so I leave it as it is. Okay, next thing we need to do, so in order to satisfy this rule, the second rule, as you move down rows, your leading coefficient moves further right, we need this term to be a 0. So typically this is the process. You get a 1 in the top left, and then you get a bunch of zeros underneath it. And then you move over and you get a 1 in the top left of the remaining matrix, and then you get zeros under it, and you just keep repeating the process. So how do we get a 0 down here? Well, we're going to use that elementary matrix operation where we can add rows together, or add multiples of rows together. So I'm going to write it over here for space. What we're going to do is we're going to take row 2, and we're going to add 5 times row 1 to it, and replace that in row 2. The reason I'm doing that is because I have a -5 here, right? So if I multiply this 1 by 5 and then add it to the -5, I'll be left with 0. So let's see that in action. So my first row is going to be unaffected. Now my second row, what do I do? So I take this -5 plus 5 times this 1 here. So 5 times 1 is 5, -5 plus that is 0. And we just repeat this process. So I take my 1 here, and I go 1 plus 5 times this guy. So 5 times -2 is -10. 1 plus -10 is -9. And then lastly, I come over here, I do the same thing. So I take -7 plus 5 times this guy. So -7 plus 5 halves. Now -7 is -14 halves. So -14 halves plus 5 halves gives me -9 halves. And then I need to make sure I'm satisfying this first rule, right? The first non-zero term is a 1. So I need to go ahead and make this into a 1. And how I can do that is just by dividing by -9. So I'm going to go ahead and I'm going to do -1/9 times row 2. And that's what I end up getting. So this is our matrix in row echelon form, REF. And now that we have it in row echelon form, we can solve it by using back substitution. So let me erase the row echelon form rules, and we'll see that in action. So just like at the beginning, what did we do? We took a system of linear equations and we rewrote it in terms of a matrix equation. We can work backwards now. We can take this matrix equation that we have in the row echelon form and rewrite it in terms of a system of linear equations. So let's do that. So our first row, remember, these numbers represent the coefficients in front of our variables. So looking at our first row, we have 1x1 minus 2x2s equals 1/2. So that's what the first row tells us. Now if we look at our second row, we have 0x1s plus x2 equals 1/2. So in reality, the second row, right, the 0x1, it goes away because it's being multiplied by 0. So the second row just tells us x2 equals 1/2. So there we go. We already have a solution to one of our equations. That's cool. Okay. Or sorry, a solution to one of our variables, rather, x2 being 1/2. Now to solve for x1, we're going to take this value and substitute it into our top equation. That's why it's called back substitution. You start at the bottom and you work your way back up by substituting in. So we're going to substitute 1/2 in for x2. So we have x1 minus 2 times 1/2 equals 1/2. So we have x1 minus 1 equals 1/2, which tells us x1 equals 3/2. So that is the solution to our equation. It is x1 equals 3/2 and x2 equals 1/2. That is the solution to that first equation. So now you're seeing the power of matrices, right? We can sort of do this. And for smaller matrices, it seems kind of cumbersome, like a lot of work just to get that solution. But you can do this for larger and larger and larger matrices. Okay, so let's see it in action for the second one now. Okay, so let me go ahead and clear my drawings. So I'm going to write the augmented matrix: 2, -3, augment with 1, -4, 6, augment with -1. Okay, so first things first, I want to get a leading coefficient here, right? A leading coefficient of 1. So I'm going to go ahead and I'm just going to multiply by 1/2. So I'm going to get 1, -3/2, 1/2. And then what do I want? I want a 0 beneath it. So I'm going to go ahead and I'm going to take row 2 plus 4 row 1s and plug that into row 2. Okay. So let's see that in action. So I'm taking row 2, so I'm taking -4 plus 4 times that. Well, 4 times 1 is 4, -4 plus that is 0. Okay, then I'm going to take this 6 here. So I'm going to take 6 plus 4 times this. So 4 times -3/2 is going to be -6. 6 plus -6 is 0. Then we do it one more time. So I'm going to take this -1 plus 4 times this. Well, 4 times 1/2 is 2. -1 plus 2 is 1. And then we have this here. Okay. Well, now our matrix is actually in row echelon form already. Because, right, remember, what do we need? We need the first non-zero coefficient in each row to be a 1. Well, we have that here. What's the second thing? We need to make sure the leading coefficients are further to the right. We have that as well. And then any row of all zeros is at the very bottom. We don't have any row of all zeros, so we technically have that rule as well. So we're done. We're in row echelon form. So let's look at solving our system now. So again, we look at each row and we convert that back into a linear equation. So we have 1x1 minus 3/2 x2 equals 1/2. And down here we have 0x1s plus 0x2s equals 1. But 0x1 and 0x2, when we add them together, we're just going to get 0. So we have 0 equals 1, which is certainly not correct. So anytime you run into that, 0 equaling any number that's not 0, you know you have no solution. Because it doesn't make any sense, right? 0 can't equal 1. So anytime you run into that, where you have a row of zeros here on the left-hand side, and then something over here that's not 0, you automatically know you have no solution. Wonderful. Well, thank you for joining me. On this slide here, I have additional resources for you. So as I mentioned earlier, I work with the ASU tutoring centers. So we have a ton of free resources for you on all 4 campuses and online. So go ahead and check out what we have at this link, tutoring.asu.edu. If you want more content like this video that goes over specific concepts in your course, or maybe you want to see what review sessions we have for upcoming exams in your course, you can go ahead and check out that link. All right, well, thank you again for joining me, and have a wonderful day.